they replace it with a diffraction grating, right? Notice it's 600 lines per millimeter, right? The D in the previous problem was like 3 times 10 to the minus fourth meters, right? So you got to look, is 0.001 divided by 600? That's a lot smaller. So these slits in this diffraction grating are closer together, right? If they're closer together, does that make these fringes farther apart or closer together, right? Now you can just kind of look at the images and just compare them, right? It's like, oh, there they are, right? Okay, so the first thing is you want to talk about the spacing of this, right? So think that through. If the slits are closer together, do you get a bigger, remember it's like d sine theta is n lambda, right? Okay, if d gets smaller, what happens to theta? Think about that, right? This gets smaller, what happens to theta? That's the first thing, right? The second thing is, notice that in the previous thing, right? See how they die off? That's a difference. Do you see? Ooh, look at that. That's a difference, right? Notice in this one how wide those peaks are. Notice that these are very narrow, right? And then the one that I didn't get was that since the light can only get through where you have constructive interference, then there's more light there, right? So it's going to be a little bit brighter. I didn't get that one. All right. Now, number 2 is one that we've done this, right? We did this as a group quiz. Hopefully you did it as a note guide and all this stuff, right? So we're going to use in section 9.4, right? We've got resolvence is lambda over the difference in lambda, right? And then that's equal to m times n, right? Okay. So how are you going to solve this? Well, we don't really care what r is, right? We've got these 2 lambdas here. So if you recall, for these types of problems, what we want to do, and not that this makes a huge difference, but we want to use the average lambda. So lambda 1 plus lambda 2 over 2. That's what you want to do. So you average those 2 lambdas for lambda. The difference in lambda will just be the difference in lambda. So subtract them, right? Lambda 1 minus lambda 2. Get that answer, right? Okay, so now you have this. You have this, right? And then which order are we talking about? Because this is our order. And then this is the number of slits that you illuminate, right? So they say it is, well, they said whether it's first or second order. So put that number in there, right? Okay, and then solve for n. N equals, boop, yeah. Okay, you're going to get a number, and the number of slits is between 400 and 500 slits, okay? If you don't get that number, then you missed the order, okay? Or you're just special when it comes to math, okay? So you'll get the number of slits. Now the question is, they don't say determine the number of slits. They say the width of the beam incident on the diffraction grating. So the diffraction grating presumably is extensive, yeah? We can imagine this, right? And the beam is only illuminating some of the slits, right? So how many? Well, what you're going to do is you're going to go n that you figured out is to 600, right? Remember, it's 600 lines per millimeter, right? Okay, n equals x is to 1 millimeter. Yeah. So if it's 600 slits, then it's going to be 1 millimeter. If it's 300 slits, it'll be a half a millimeter. Okay, solve for that. And the answer is less than a millimeter, but more than half a millimeter, I'm just going to say. All right, happy hunting.